In this session, we can enter into discuss the next subtopic of this model that is already I've told you. That part is actually elementary matrix. That is quite easy. So we can complete the session in a short period of time. So if you could understand one problem, then it could be easy to solve the remaining problems also. Okay. But to be opened, this problem won't be as in as a single 10 mark. Okay, so this will not place in the 10 mark as a 10 mark worthy problems, but the steps what you are going to follow there, that may be useful in the 10 mark problem. So that's why I just keep solving some problems on this. It is more than enough to understand only one problem on this, then it is quite easy to solve the rest of the problems. Okay, so here the elementary matrix. So usually the word you have already gone through in the preceding classes, like elementary means it's a basic elementary operations. So elementary row operations you are already discussed in the same model. Like elementary row operations means you are just applying the addition or subtraction or whatever may be the row operations. By involving that elementary row operations, you are transform the given matrix into the echelon form. So in that case, you would have come to know the word elementary. So that is elementary row operation. So here elementary matrix is nothing but it is quite related with the matrix, another matrix, that is identity matrix. That is a basic matrix. You are already known that. That is identity matrix will be in the form like 1 0 0 1. If it is a 2 by 2 means you can write the identity matrix as 1 0 0 1. So if it is a 3 by 3 means 1 0 0 0 1 0 0 0 1. These and all you already known that. Okay, now elementary matrix, how the way it is connected with identity matrix. The definition says like elementary matrix is a matrix. Okay, it is derived from the identity matrix. How the way it can be derived? How the way it can be derived? So there are restricting here one condition. What is that condition? You have to apply one time elementary row operation. Listen carefully. Only one time, not more than that. Okay, exactly only one time. If you are applying the elementary row operation in the given matrix A, then you will be derived one elementary matrix. That matrix will be denoted as maybe E1 inverse or E2 inverse or E3 inverse. That's your wish. Okay, so such derived matrix by using exactly one elementary row operations applied on the given matrix A, this matrix, such derived matrix, is called elementary matrix. Definitely you're not understood on this definition. I can feel that anyway. So now I can enter into the problem directly so that you can understand the concept in an easier way. Okay, so these are some examples of the derived elementary matrices from the original matrix E. Okay, see here, if still doubts on this, not an issue. I can help you in the next slide about how the way it can be derived in a detailed manner. Okay, see here, this is the matrix. Okay, E. So from which E inverse, that is elementary matrix, it is derived from the concept by using the identity matrix. So there you need to apply that like your to convert that term as like 1 by C means, then if you could apply the multiplication, you can get the same identity matrix. Okay, so by the same way they are given another two examples. Okay, please don't worry, even if you are not understood up to this. Okay, you can definitely understand on this problem. Okay, the question can be asked you in that manner only. Okay, so express the following matrices as the product of the elementary matrices. There is one theorem says, the theorem says like product of all the elementary matrices, product of all the possible elementary matrix should be equal to A. That means E1 inverse E2 inverse, E3 inverse, E4 inverse. If suppose if you are derived 4 possible elementary matrices from the given matrix A, means if you are applying the multiplication between them, you should get back the same original matrix of given A. Okay, that is the theorem says. If you want to refer, that means you can please refer that book. You can get the idea. Okay, so one more thing I forgot to share with you, that linear algebra book, applied linear algebra book, as a PDF. I think some of the guys are maybe already downloaded from the online sources also. If not, means not an issue. Please remind me. I can just share the file in the comment chat so that you can utilize that. So that book is quite easy to understand the concepts, because they are presented in a very basic manner. So if you could read the concepts, you itself can understand the problems. Okay, so okay, this problem, your task is assigned here to determine to project the following matrices of, that means this matrix can be written in the form of product of all the elementary matrices. First, I need to determine what are all the elementary matrices can be derived for this matrix A. That things I need to understand that. So first, already I have told you elementary matrix definition is it's a matrix derived from, obtained from identity matrix. Okay, so first my part is assigned here to convert this A into the identity matrix formation. See here the same procedure as you already known that. So there is no change in R1, so I can apply the change in R2. So 1 minus 3, so R2 gives R2 plus 2R2. So in that case 0, then 4 minus 6, so minus 2, then okay, can anyone try to guess what is the next rule I should apply?
So in the first operation, it will be R2 plus 2R1.
Very good. R1, sorry, 2R1. Yeah, thanks.
First one.
Yeah, thanks. Okay, so now
it will be R2 by minus 2 divided by minus 2.
R2 gives R2 divided by minus 2. So 1 minus 3, 0, 1. Okay, only one more. Any guess?
R1 is equal to R1 plus 3 R2.
Very good, super. So here 1, so 0, 0, 1. So listen carefully. This is quite important step. So you are converted the matrix into the form identity matrix. So the definition says to derive elementary matrix, it can be obtained from the identity matrix. Okay, so to convert such identity matrix, what are all the elementary row operations you are used there? That has to be marked because that is very important on this. So totally I have used 3 elementary row operations. So definitely I will be getting here 3 elementary matrices. Okay, listen carefully. I am repeating the same. So whatever may be the number of row operations you are used to convert the given matrix A into the form identity matrix, that number of row operations will be formed as the elementary matrices. That is the concept says. Okay, so finally it will be proven that in that time you can easily understand. So now my task is assigned here to determine E1 dash. That E1 dash can be determined, listen carefully, can be derived from the case R2 gives R2. See here, if you write in the elementary matrix derivation, you have to write R2 gives R2 if you are used plus symbol between the rows means you have to use the opposite symbol, opposite sign. R2 minus 2R1. If it is minus means you have to use plus here. So this is the first rule to apply your E1 dash. So in E1, okay, in E1 you can consider like 1 0 0, so 1 0 0 1. So if you are applying in R2, the rule of R2 minus 2 R1 means what is the value will come on this? Any guess?
Minus 2 1.
Minus 2
1.
1.
Fine. Next. So the second rule says like to derive the E2 dash, that is R2 gives, definitely the question will come. Sir, here R2 divides by minus R2 you are using here. When you write in a way like R2 gives minus 2 into R2. So that means if there is a multiplication there in the left hand side, you have to use there in the right hand side as the division. If there is a division means you have to use in opposite way multiplication. That's it. So R2 gives minus 2 into R2. So E2 gives implies like what is a 1 0. So next one is 0 minus 2. Okay. Further extension.
Sir, 4.
Yes.
Oh, no. No.
So next, last one is R1 gives R1. Any guess? R1?
Minus 3 R2.
3 R2.
Very good. So here E3 dash is equal to, so 1 0. What is the value will come? 1 minus
1 minus 3.
1 minus 3. Okay. Second row, there is no change. You can use it as in the form. So now, as per the concept of elementary matrix, there is one theorem is given. Okay. So if you refer that, elementary matrices product will be equal to the given matrix A. So A equal to E1 inverse, E2 inverse, E3 inverse. So let us check whether it will be equal to that. Like first one is 1 0 minus 2 1. 1 0 minus 2 1. Second one is 1 0 0 minus 2. 1 0 0 minus 2. Third one is 1 minus 3 0 1. So someone can help me to apply the multiplication between first two matrices. I think 1. Next 0 minus 2.
Minus 2.
Again minus 2. Am I right?
Yes, sir.
Yes. Sir.
Then what about this?
1
1
minus 3
Minus 3
minus 2
minus 3.
6.
4 plus 4 plus
yes.
4.
Oh, and please check 1 minus 3 minus 2 4. Okay, so you have proven express the matrix as a product of elementary matrices. So this is the way to determine the elementary matrix as well to cross check whether you have obtained the correct elementary matrices for the given matrix A. By applying the product between them, you have to get back the same matrix A. So this is what you can follow in the 3 by 3 also. Okay, in your 10 mark problems, this will be one part to determine your elementary matrices. Like if it is in a 10 mark, I'll intimate you once the model comes. That time, in that case, you have to find E1 inverse, E2 inverse, E3 inverse. There it will not be provided for 2 by 2 dimension. It will be providing for 3 by 3 dimension. The same rule you are going to follow there also. Simply first you need to convert the identity matrix in the dimension of I3. To convert such I3, what are all the elementary row operations you are used there? Such row operations should be listed one by one as E1 inverse finding, E2 inverse finding, E3 inverse finding. After that, if you want to cross check, you can take a multiplication between all the elementary matrices. You can get back the same original matrix A. So very, very easy one. So have you understood on this method, elementary matrix method? It's a small one. Is it clear?
Sir, why we are not converting multiplication into division?
Yeah, we have to do. If there is a multiplication there in the left hand side, you have to convert in the right hand side as a division. Like you are asking about like 2R1 or which one you are asking?
Yes, sir. Like that one, 2R1, 3R2.
Okay. Actually, that part should not be made because see here, that is a coefficient of the row. Okay. So here, what is the connectivity used between the two rows? Okay. In that part only, you have to follow that operation change, like plus will be changed as minus, minus will be changed as plus, division will be changed as multiplication, multiplication will be changed as division. Okay, these are some rules in the elementary matrices. Between the connectives between the rows connective, you have to change in the order. You should not change like minus 2R1 means like R1 by 2. No, if you use it, you will not get the answer.
Okay, sir.
Okay. Actually, these and all, it's like a concepts, how the way it can get back the same original matrix A. So they are prescribed some procedures for the same. They are given this as a theorem. If you could refer that book, in that case you can understand why they are splitting in that manner. But I am projecting here in the problem wise, so that it could be quite easy to, if you are really interested, when you refer that theorem means, in that case you can definitely understand. But that theorems, if you if you study directly, then that will be the hot topic that you can really feel like a hot topic. So that's why I just eradicated that. Even in your syllabus, that is not asked. So as like problems only, it is given there. Okay, fine. So please fill the attendance form quickly, then you can please come back. Yes, I have posted the attendance link in your meeting chat. Please fill the attendance form quickly. Okay, fine. See, in your syllabus that from model 1, we have completed Gauss elimination, Gauss Jordan, and then elementary matrices also. So inverse matrices we have completed in the exact previous session. So rest of the topics like a system of linear equations also you have solved. So system of linear equation and then LU factorization are combined in the same subtopic. So usually if the 10 mark comes like from this model, you can expect from either Gauss Jordan or Gauss elimination or from LU factorization. Okay, because this could be the worthy to ask that. Most probably, like instead of Gauss elimination, it will be preferably to ask from Gauss Jordan only. Okay, because I hope you can understand the number of steps between the methods, so that's why they are preferred from Gauss Jordan only. So LU factorization method. Okay, I'm not going to enter into the topic now, so I can just give the 2 minutes description about it, then we can sign off the meeting. So please listen. So LU factorization method means, in that thing you need to know first what is L, what is U. Okay, so here like LU factorization method is also to be called like a LU decomposition method. Okay. Given matrix will be decomposed into the form L and then U. What is that L? What is that U? Definitely that question will arise. So here L is nothing but, see here, L is nothing but lower triangular matrix. Okay, this technical term definitely you would have gone in your schoolings. Like lower triangular matrix means, so the matrix will hang only below to the diagonal. The entries will hang only below to the like 2, 3, 4 or something like. So here 1 or something. So any guess? What about these terms? Any guess? Zeros. Very good. About to the diagonals will be zeros. Okay, it can form on good shape. In your upper, that is completely opposite. Okay, see here the elements, non-zero elements will be there in the top. That means above to the diagonal. Like below to the diagonal elements will be like zeros. If you could Google it, you can get some examples. So instead of writing, so you can matrix examples. Yes. Yeah, I'm going to this. Yes. See here. This is L, that means lower triangular matrices. So they are shown in the triangle. Okay, all the elements are like zeros. This is upper triangular matrix. So in your LU factorization method, you are going to involve in the steps of same elementary row operations until you convert the given matrix into the form L. Okay, then U. Okay, once if you are proceeding that, simply you need to take a product between them. Anyway, further steps will be discussed in detailed manner in the next session. Okay, so in this thing, the permutation matrix is given as a definition. Okay, that I can just assign that on small work to you. Like you can just take a refer on this because it's not quite important. Also, it is not involved in your problems. Okay, just to know, I'm just giving that as a slide to come to know that. So if it is required, you can please take a look into it. It's just permutation matrix. It is also obtained from a identity matrix, but there is some additional thing they are doing, that is changing the order. Okay, order of the rows, that's it. So that is a permutation matrix. It is not required. If it is really needed, you can please take a look into that. But there will not be problems coming from this permutation matrix. Okay, if any other doubts up to this topic, you can please interact with me now. Okay, if there is no doubt, we can conclude the meeting. Thank you all. Thank you.
Thank you, sir.
Thank you,
sir.
Thank you, sir.
Thank you all.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you all. Thank you.
Thank you, sir.
Thank you.